Hello, welcome to this new edition of InSite Bytes. Today we're going to have a look at what tools we have in InSite to work and extract more information from seismic catalogs. As you probably know, what we mean by seismic catalog, it's a list of seismic events that have been processed by different vendor, different institute, different processor. That includes the main characteristics of our seismic events, mostly location and magnitude, some of them, and time, of course. And some of them also include some further information, such as radiated energy, source radius, etc. There are many publicly available seismic catalogs at different scales. We can see here two examples of tectonic earthquakes that have been recorded in the last day, as we see here, or historical records for a longer time period. So we can import this data into InSite and analyze and extract more information from them and display them in a way that it's more convenient for our project that suits our investigations. So, how do we do that in InSite? Well, first step is preparing the data as we import. Normally, it's imported as text. For importing to InSite, we need to save them as CSV files following this format that is shown here, including the main information. We don't need to have information for all fields. The CSV file is very comprehensive, but we just need to enter the information that we have, that we are provided with. So let's have a look in InSite. Let's open a project in InSite and work with the seismic catalog. And of course, first step is import our data. We select the CSV format. This is the text format that we have just seen. We have some options, whether we want to merge all the data into a single component, or whether we want to select which fields we want to import. In this case, we're going to import everything, so we don't need to do any further selection. And I'm going to import this CSV file that I have prepared before. And here it is. In this case, I've imported some data from the seismic series that was centered in Santa Fe in Granada, in southeast Spain, in early 2021. We have here a list of over 1,700 events that, well, you can see started imported data from September 2020 up to the last events that were recorded in February in 2021. Right, so let's have a look in the 3D Visualizer. And here we have our data. It's displayed here with the bitmap capture from Google Earth. This is an option in the 3D Visualizer to import bitmaps, and it's always useful to have a reference, a geographical reference, also a scale reference for our seismicity. We can see there was the seismic catalog did not have enough depth resolution. The resolution was 1 kilometer. So, yeah, you can see this is reflected by this apparent layering in our events, which is not, it's just an artifact of the low resolution in depth. But still, well, the map view, the plan view, can be informative. I'm using here some of the options that we have in the 3D Visualizer, which is using a different color scale using time in this case, and a size scale using magnitude. And this helps in basically trying to map where our major displacements, major earthquakes in this case, occurred. The magnitude 4 events were following this lineation. And we can also see the location of all the rest of the smaller events and the aftershocks. But there's much more we can do with our seismic data apart from display, which is always useful, is the main source of information. But the charts in InSite allow to get more information out of our events. Not only where do they locate, but also it's always very interesting, it's very useful to analyze the distribution of magnitudes. And we can probably extract information about the source, about the seismogenic zone as well, the behavior of it, if we look at the distribution of magnitudes in our series. So that is done by analyzing the B value. So we select it, we launch it, and here we have options. There are two types of charts, three types, sorry, two temporal lines, and one which basically just takes all of the enabled events in consideration and displays the typical Gutenberg-Richter distribution. And let's have a look at it as by default, as it's working by default. So click on launch, and here we have it. So you probably know B value, or we call B value, it's the slope of the linear section of our chart, of logarithmic chart of magnitude distributions in our event catalog. Here we can see our largest magnitude event was just under 4.5 in magnitude, and the smaller event that was recorded was around 0.5 positive magnitude. So we can see the distribution, it's flat below these small events, and it's got a linear section which we can customize, and it's automatically fitted, get the linear regression fitted to it, and it's giving us an average B value of 0.9, which is very close to what it's defined as the default, the standard value for tectonic areas. But there's more we can do with this. I've prepared this once before. Have a look. We can also look at the changes in the B value in time. Here we are using them instead of time, we just use equal size bins of 100 events, and we can see the evolution from the start of the seismic swarm up to the end, the evolution of the B value. High B value normally means an increase in the number of small events. It's also associated with high heterogeneity, also typically associated with induced events, induced seismicity, or man-made seismicity. But yeah, we can actually link the minimum and the maximum of this B value with the occurrence of the highest magnitude events. And it's an analysis that InSite allows you to perform. You can, of course, by clicking on properties, customize this. You can, for example, show the rolling average, which sometimes, it's more informative, that it's less prone to being biased by single events of higher or low magnitude. You can see there, and we can also, of course, change the number of bins that we're gonna use if we want to get more detail and we have enough number of events, we can increase the number of bins, for example. Yeah, and we get probably a more detailed information. Other charts that we can use is the chart of what is called, let me check, is the D value chart. For example, I'm going to launch it. And this is a statistical analysis. It basically looks at the inter-event separation. Well, sometimes it's used to look into the deviation of our seismic cloud from what would be a 3D distribution. So this D value, it's almost like the spatial dimension, but what it's telling us is if it's around 2, our events are more distributed in a plane, along a plane, so are basically defining a plane. If it's close to 1, it's closer to the line, and if it's close to 3, we have a more volumetric 3D distribution. In this particular case, this analysis is probably not correct because, as I mentioned before, we have a very low depth resolution, and so yeah, we are losing some of the spatial resolution that will be required to interpret any changes that we have in this D value. And other informative charts that we can use in InSite, for example, it's just a simple histogram of occurrence, just telling us when most of our events occurred. We can look at the distribution of magnitudes. So yeah, you can see here most of our events in this case were around the magnitude in between 1, 1.2, 1.3, etc. So as you see, there's a lot of information that you can get from analyzing seismic catalogues. And it's mostly to characterize seismogenic zones or fracturing processes, depending on the scale that we are working with. So I hope this was useful. If you have any questions, of course, we are always here for you at asc-info@applyseismology.co.uk. For any queries, any questions that you have, counter doing your use of InSite. Thank you very much for your time, and see you in the next edition of InSite Bytes.